All right. This is verifying trig identities. Okay, so if you have your notebooks out, that's your title. You can put 5.1 class discussion. There are some things, some people like to take screenshots. That's fine, and take your notes later. And this will also be available after we're done. Okay. I'm going to put Sarah, you are in charge of telling me every now and then. Mr. Delgado, check your participants, because sometimes I forget and people are in the waiting room. Okay, so just remind me. Okay, thank you. Our objectives, we're going to use the fundamental trigonometric identity to verify identity. It's going to be very important as we move forward. The next lesson, we're going to talk a little bit about proofs, and we're going to get to see how that plays out. All right, so there's my crazy lag. The fundamental identities. So what are the fundamental identities? We have three types: reciprocal identities, we have quotient identities, and we have Pythagorean identities. Okay, those are our three types. We're going to start off with reciprocal identities. And they're a little bit different than just a reciprocal. If I asked you for the reciprocal of sine of x, what would be the reciprocal of sine of x? Anybody? Okay, I got it, Sherman. Your camera's not working, just to let you know. No worries.
One over cosecant of x.
That is the reciprocal identity of sine of x. But I said the sine of x, what's the reciprocal of sine of x?
1 over sine of x.
There you go, 1 over sine of x, right? The reciprocal identities are different than the reciprocal of just your trig function, okay? And the reciprocal identities, this is, and you're wondering, how do you get to 1 over cosecant of x, right? Because it's 1 over cosecant if the reciprocal is 1 over sine of x. Well, how did they get there? We, just as, I don't know who was it that said the answer. Who said the answer? They're not talking now. They can't find their microphone. So 1 over cosecant is 1 over sine, right? So how do you get from one to the other? Well, that's like writing this complex fraction, 1 over sine of x, right? And dividing, this means dividing, right? So we can rewrite this complex fraction as 1 divided by 1 over sine of x, and dividing is the same thing as multiplying by the reciprocal. And when we multiply by the reciprocal, you see that you get 1 times sine of x. So that's how you go from sine of x to 1 over cosecant. Does that make sense? Okay, so that is the reciprocal identity. Again, this is different than the reciprocals, right? So what is the reciprocal identity of cosecant of x? Well, this one we know. This one we should know. This one is what? Cosecant of x is the same as?
1 over sine of x.
There you go, 1 over sine of x. So now, we're going to take a look at the rest of it. Cosine of x, what would be the reciprocal identity of cosine of x?
1 over secant of x.
1 over secant of x, right? And secant of x?
1 over cosine of x.
1 over cosine, good, Anthony. Okay, 1 over cosine of x. And tangent?
1 over cotangent of x.
Good job, Sarah. 1 over cotangent of x. And
1 over tan x.
1 over tangent of x. Good, Christina. Hi, Christina. Haven't seen you. Pretty flower.
Thank you.
All right. So let's see here. Those are the reciprocal identities. Quotient identities. Quotient identities. What are those? What are those? Tangent of x.
Sine of x over cosine of x.
Sine of x over cosine of x. Good, Anthony. And cotangent of x.
Cosine of x over sine of x.
Good job. We just flipped it. Good, Christina. Okay. So now, and last but not least, we have the Pythagorean identity. Pythagorean identities. Okay. If you think of Pythagorean identities, that means they're related to the
Triangle.
To the triangle, right? Not just any triangle, but the
Special right triangle.
special right triangle. Which special right triangle? The one that has a hypotenuse of?
Square root of 2.
Hypotenuse of?
1.
1, right? The unit circle is what we're talking about here, right? So Pythagorean identities are related to the Pythagorean theorem, and we know in the unit circle that hypotenuse will always be a 1, right? So just to refresh your memory, a squared plus b squared equals c squared. In this case, it was sine squared of x plus cosine squared of x is equal to?
1.
1. Good job. Good, Myra. Okay. So now, what if we took this Pythagorean identity and divided it by cosine of x? Took everybody here, and we're going to divide them by cosine of x. What would happen? Okay. What would we get? This one here, sine squared of x over cosine squared of x, that's going to give me what?
Tangent squared of x.
There you go. Good. Tangent squared of x, right? And then take the next one, which is cosine squared of x over cosine squared of x. What's that one going to give me?
1.
That one's going to give me a 1, right? So now I have tangent squared of x, and I have a 1. So it's going to be plus 1, or the other way around. The question is, what's this one going to give me?
Secant squared of x.
Secant squared of x, right? So now 1 plus tangent squared of x is going to equal the secant squared of x, right? What if instead of dividing it by cosine squared of x, we divided it by sine squared of x? What's that going to do? This first one is going to become what?
1.
It's going to be a 1, right? And what's this one going to become?
Tangent squared.
Cotangent squared. Very good. Cotangent squared of x, right? That was going to be cotangent squared of x. So that makes this last one
Cosecant squared of x.
secant squared of x, right? Because this last one is 1 over sine. 1 over sine is cosecant, so that's going to make it cosecant squared of x. I'll give you a minute to write those down, right? Anthony, I just saw that you wrote your answer in part as a chat. I'm sorry. I'm still getting used to doing multiple things at once. So funny. In case you missed it, right? I know y'all missed it.
You're going to have to change your thing. Instead, it's going to be like, take a screenshot. It'll last longer. Take a picture.
Keep commenting and take a screenshot. It'll last long. I'll put funny slides in between. I didn't think about doing that. Good idea, Christina. I like it. All right, we're good?
Yes, sir.
Here we go. This crazy lag. There we go. So even and odd identities. Okay, which identities are even and which ones are odd? So let's just think back to when we talked about functions. If a function is even, f of negative x is equal to what?
F of x or negative f of x.
Right? And if a function is odd, f of negative x is equal to?
Negative f of x?
Negative f of x, right? That's an even function and an odd function. And if it's neither one of those, then it's neither even nor odd. Okay? Of these, just tell me one. Tell me one function that is even. Tell me one function that is even.
Cosine?
Cosine. Cosine would be one that is even. Tell me another one that is even.
Secant.
Secant. Secant is the other one. That was you, Sherman?
It was me.
Recon.
I got somebody else coming in. Good job. So those are the even ones, right? So the question is, which ones are the odd ones? Those are
All the other ones.
all the other ones. Very good. All the other ones are odd. Good job. All the ones are the odd ones. Crazy line. Crazy, crazy computer. Gonna get rid of you. Oh, I forgot I'm recording. All of that is being recorded. Alrighty, so all the other ones are odds. This is going to become important as we discuss the next section. Okay, so keep that in mind. Here they discuss it a little bit and they start to introduce it, but not Not that emphasized here, but you'll see where it plays a part next section. Using fundamental identities to verify other identities. So let's take a look here. How do we verify identity? Verifying an identity is basically you're doing an algebraic proof. You're trying to prove that the two sides are equal to each other or that your identity is true, right? You're trying to prove that your identity, both sides of your identity are equal to each other. There will be times where one side will be more difficult than the other, and you just need to solve one side and make sure that you get what's on the other side. But there will be other times where both sides look interesting and they look challenging. So that means you work with them independently to eventually end up in a place where you can compare the two and say that they are equal. Okay? So to verify an identity, we show that one side of the identity can be simplified so that it is identical to the other side. Each side of the equation is manipulated independently of the other side of the equation. You start with the side containing a more complicated expression. So you're going to start with the difficult one. You start with the hard one always, okay? Doesn't matter what that side is, the left side or the right side. Whichever one is harder, you work with that one first, okay? And if you substitute one or more of the fundamental identities on the more complicated side, you will be able to rewrite it in a form identical to that of the other side, okay? So you work with one side, try to see if you can end up with the easier side. If both sides are difficult, then you need to simplify both sides, okay? So let's do some problems. This is problem one, so write this down. Example one, you are changing the sine and cosine to verify the identity, okay? So here's our first identity. That's your problem. Cosecant of x tangent of x is equal to secant of x. Which side looks more challenging, the left or the right?
The left.
The left definitely looks more challenging, right? Cosecant x tangent of x, right? And they're giving us a hint. They're telling us to change it to sines and cosines. Again, the more problems you do, the easier it gets. Okay, the more problems you do, things are going to become more familiar and you'll become more adept at doing them. Like I said, none of what we have left is difficult. It is just new stuff. And this is going to seem very familiar because it's just like working with algebra. These are algebra puzzles. When I stopped thinking of them as problems and started thinking of them as puzzles, math became so much more fun. So we're going to have fun with this side, right? Now that looks difficult, Delgado. I have no idea what to do. Well, you do, okay? Let's start off with what we know. Cosecant of x is equal to what?
1 over sine of x.
1 over sine of x. I know that, right? And tangent of x, what does that equal?
Sine of x over cosine of x.
Sine of x over cosine of x. Good job, Myra. Okay, so I know this, right? So I can take both of these fractions and replace them with what's there, right? Instead of writing cosecant of x, I'm going to put 1 over sine of x. Instead of tangent of x, I'm going to put sine of x over cosine of x. Can you see what happens now? Math just became very, very nice to us, right? What's going to happen here?
One over cosine of x.
Right, so what happened to the sine of x's?
It canceled out.
It canceled out, right? I have one in the numerator, one in the denominator. They're being multiplied, so they are going to get canceled out. Those two get canceled out, and I end up with 1 over cosine of x, which we know 1 over cosine of x is going to be the same as what?
Secant of x.
Secant of x. Good, Anthony. Okay, that's going to be secant of x, which is what we were trying to get to, right? So we've verified the identity, right? Everybody got that down? Always, always, as you're working through one side, make sure that you don't forget what's on the other side. So look back to make sure that you know what you're trying to get to. That's a hard part, right? I see that you wrote something else. I'm a little late here. I'll get to it. Don't worry. I'll get to it eventually. Got to manage all three. Got to manage all three. People coming in, people writing, people talking. Manage it. My computer's not helping. I'm going to blame it on my computer. Okay, so this is example 2. So we're using factoring to verify. Okay, so copy it down. This is example 2. It says sine of x minus sine of x times cosine squared of x is equal to sine cubed of x. Which is the easier looking side, the left or the right? Which is the easier?
Right.
The right. The right is definitely the easier side. See it? Yeah, I see it exactly. Good job. Okay, so the right is definitely the easier side. Okay, so I'm not going to work with that one. I want a challenge because I love me some math. So I'm going to work with the
Left.
to the left, right? So we're going to work to the left, right? So let's look at the left. What do you notice that you have in common here in both terms that are on the left? They both have a what?
Sine of x.
Sine of x. Good, Martin and Anthony. Sine of x, right? So sine of x. So what am I going to do with that sine? I'm going to
Factor it.
factor it, right? I'm going to factor the sine of x. So I'm going to factor the sine of x out, and that leaves me with, remember, if all I had was sine of x, there's always a 1 there, even though we don't see it. So I'm going to end up with 1 minus cosine squared of x. Now, Delgado, this looks different. I don't know that it looks simpler, but it definitely looks different, right? So let's take a look at that 1 minus cosine squared of x. I don't remember that being one of the identities. However, if you think of your first Pythagorean identity that we discussed today, it was sine squared of x plus cosine squared of x equals 1, right? So what would happen if I subtracted cosine squared of x from that equation? What would I end up with?
Sine squared of x is equal to 1 minus cosine squared of x.
There you go, right? So if I subtract the sine squared of x and move to the other side, I'm going to end up with 1 minus cosine squared of x, right? Got it? So what does that mean? That means that I can replace that 1 minus cosine squared of x with sine squared of x. So I'm going to take that sine squared of x and replace it. Right? So that's going to be in there. Got the idea? Now I'm liking it. Now it's looking a lot better, right? All I need to do is multiply that, right? If I had 7 times 7 squared, that would give me 7.
Would it be cubed?
Cubed, right? So now I have sine times sine squared, so that would give me what?
Sine cubed.
Good job. Good, Sophia. Good, Myra. Okay. So I got sine cubed of x. Got it, just no? And that verifies the equation because that's what I was trying to end up with. We good? This is so easy. Baby can do. So easy, baby can do. All right, we ready? We good? We move on. Ooh, that looks cool. So now we have fractional expressions, right? This is example 3. Write that down. Example 3. That is your example. Which of these two looks like the more challenging one, the left or the right?
The left.
Left side.
The left side, right? The right looks easy. So I'm going to work with the left side. I don't want easy. I want something that's a challenge. It's going to make me very nice and happy to do some math for the day. But let's work with that, right? And notice those two fractions don't have a what? I need to have a what if I want to add them?
Common denominator.
Common denominator, right? So what's going to be my least common multiple denominators, also known as your least common denominator, aka your LCD. What's that going to be? What is the LCD?
1 plus cosine of x times sine of x.
There you go. Sine of x times the quantity 1 plus cosine of x. That's going to be my LCD.
And then you can, from the previous question, you can look at how that was just sine cube x.
Say again, Christine?
Since like in the previous example, like we looked at how sine of x and then parentheses 1 plus cosine of x, that was the same as cube of x, wasn't it?
Yes. So that one was 1 minus though.
And the cosine squared.
Oops.
And it was also squared, correct. This one's not squared. So we do one step at a time. You'll be able to do that later, Christina. You'll be able to skip steps because you'll see these things. We're going step by step, and eventually all these things will just click like they normally do, and you'll be able to skip steps later. But try not to at the beginning because a lot of it is new. Once you're ready for it, if this makes sense to you, then go. You know, go from one to 1,000. I know a lot of you can do that. But until you get there, let your brain, let it sit for a while. Your brain will let you know when you're ready to do that. So now on the left, right, what's missing on the left? We're missing sine of x, right? So I need to multiply sine of x on this side. But on the other side, what's missing?
1 plus cosine of x.
1 plus cosine of x, right? So I have to multiply it like that. But in math, we're not just allowed to multiply numerators by whatever we want, whenever we feel like it. However, we are allowed to multiply by what number just because we feel like it?
1.
1, right? So another form of 1 is going to be helpful here for either side is going to be sine of x on the left side, and on the right side 1 plus cosine of x. Everybody get the idea?
Yes.
Yes? So now all I need to do is multiply these together. All I need to do is multiply these together. So I've got my common denominator, which is sine of x times 1 plus cosine of x. And now I need to multiply the numerators together. So sine of x times sine of x is going to give me what?
Sine square of x.
Square of x, good Waken. Okay. And on the other side, 1 plus cosine of x is going to give me
1 plus 2 cosine of x plus cosine square of x.
There you go. Okay. Notice the other side, you have a binomial squared, right? A binomial squared. So you have to use FOIL. If you remember the rule, it will probably save you some time, right? These binomial squares and the differences to binomials, sum of two binomials, all those rules are going to become very useful. So why commit them to memory for cases like this? You saw how quickly Wakeman was able to do that in his head, right? Because he probably remembered that from Algebra 1, okay? So now we have this, now I have a common denominator, so I can rewrite this, right? I can rewrite this under the same denominator. And then all I need to do is add my numerators, right? This was from the previous screen, so don't worry, it's the same thing you had on there. Now I'm just rewriting it under the same denominator. And now I'm looking for things that look familiar, right? I know one of my Pythagorean identities, right, dealt with sine squared and cosine squared. So I can regroup those guys, right? I can regroup those two guys, put them together to see if that will be a helpful, right? A helpful thing, right? If you recall, sine squared of x plus cosine squared of x is equal to
1.
1, right? So if I put these together, right, I can replace that whole piece for a what?
1.
For a 1, right? I replace all that with a 1, okay? So I'm going to take that and replace that for a 1. If my live will stop, maybe. There we go. Got it? Just no, maybe so. And 1 plus 1 is
2.
2. Right? It's looking better, Delgado. It's looking better. So now what can I do with those 2's in the numerator? I can do what? I have two,
Factor.
two 2's in them.
Factor.
Factor.
Sure. Good job. I can factor out the 2's, right? I can factor out the 2's. So I'm going to take the 2 and factor out the 2's, right? And I end up with 1 plus cosine of x. And I have 2 times the quantity 1 plus cosine of x over sine of x times 1 plus cosine of x. And what's going to happen? Math is so cool. You see what happens now? what happens?
They cancel out.
They cancel out. Love it when that happens. That is so cool. Blam, blam. And now I have 2 over sine of x. Now I can factor out that 2, right? So I end up with 2 times 1 over sine of x, right? 2 is the same as 2 times 1. So I can split those apart, right? And 1 over sine of x is what?
Cosecant of x.
Cosecant of x. Good, Christina. So 1 over sine of x is cosecant of x, which is what I wanted to end up with, right? So that means that I have verified my identity. I'll give you a minute to finish writing that. I'll give you more writing. Got the idea? That was so much fun. I want to do another one. Who wants to do another one?
Let's do another one.
I'm going to straight up lie and say that everybody was doing this.
Yeah, more math.
More.
See, more. See, that's what I'm talking about. Yeah. Talia's going, yeah, more math. Yeah, more math.
What's life without math, Dorado?
Huh?
So what's life without math?
What's like, I agree. I agree. I feel you. I'm with you on that one. Has no meaning. It's not the same. All right. So here we go. Last one. You're going to love this one.
Oh, fun. Theta's involved now.
We got theta instead of x. So they wanted to change it up on us a little bit. Okay. So in this one, and I just want, just for my own curiosity, okay, how many people think that the left side is the more challenging side? Give me a thumbs up, or you're on your screen, thumbs up. Okay. How many people think, I just got 1, 2. Okay. So how many people think the right side is the more challenging one?
Oh. I feel like they're equal because they both need work.
Got 1, 2. So it's
Oh, wait.
a lot. And a bunch of people say, I have no idea what you're talking about. So I'm going to go with, in this one, they're both kind of, neither one is easy. And it doesn't matter which one you pick. So this is the type that you're going to have to work on both sides and hopefully end up with in a place where they both equal each other, right? So we'll start off with the left side. We'll start off with the left side, okay? So let's take a look at that. First thing I need to do, I've got 2 fractions, so what do I need to find? I need to find the
Least common denominator.
least common denominator, right? So what's going to be my least common denominator here? I need to multiply those 2 together, right? I don't have a choice. So on the left side, I'm going to multiply by
1 minus sine of theta.
1 minus sine of theta, right? And on the right side, I'm going to multiply by
1 plus
1
sine.
plus sine of theta.
plus sine theta, right? So notice it gets bigger. It's a little ugly, but it's going to work itself out. Now I can just use a distributive property and rewrite all these under the same, or actually I should say over the same denominator, right?
Would it just be like 1 minus sine squared theta?
So it's going to be what? When I distribute this one, it's going to give me 1, right? Minus sine theta, and then I have to be what? Plus, and this is going to be what?
1 plus sine theta.
1 plus sine theta. Good
This
way.
is like a the difference of 2 squares, isn't it?
Oh,
They're conjugates.
yeah, kind of, sort of, ish, right? So you see that? That's where you end up. Everybody okay with that?
Mm-hmm.
And from here, math gets easy. What happens to my sine of thetas?
They cancel out.
Cancel out.
So I got a positive and I've got a negative, right? So they're gonna cancel each other out. And what do I end up with? 1 plus 1, which is 2. 1 plus 1, which is 2, right? And now, this is what Christina was alluding to earlier. That denominator, right? I can multiply it out, right? If you recall, a plus b times a minus b gives me a squared minus b squared, where a is 1 and b is sine of theta. And and this is what she was saying earlier. 2 over 1 minus sine squared theta.
That is so fun.
Yeah, that is fun, right? I like that. That's a fun part. Very, very puzzly, very structured, very easy. So we're going to leave it there for right now. We might.
No.
You could just make it 2 secant squared of x.
You could.
I mean-
You could go that far. In this problem, they left it here, so I'm going to leave it here, and I probably would do exactly what you did, Anthony.
They're leaving us at a cliffhanger.
What was that?
They're leaving us at a cliffhanger.
Yeah, I think it's yeah. I didn't agree with the way they did it, but I just didn't want to go any further. I wanted to leave it there, but yeah, I would agree with you guys. I would have done it that way, the way you did. So at least we got to a point where it looks better than where we started, right? Agree?
Yes.
We agree on that. Okay. Good, Mark. So thank you for agreeing with me. I appreciate that because Anthony and Christina want to keep going. So, so let's take a look at the other side. Okay, let's take a look at the other side. 2 plus 2 tan theta. We've done this side. We've gotten to a point where we can kind of see that it's gotten easier, right? So if we can get this side to look like the other side, which was what again? Where do we stop?
2 over
1 minus
sine theta.
There you go. 2 over 1 minus sine theta. So if we can get this one to look like that, then we're okay. And always look back to make sure that you know where you're going, okay? Well, let's start off here. Now, there are many ways to get to a solution. There are quicker ways and more difficult ways. I think they did it this way because they wanted you to kind of there are different ways to get to an answer, and there are some quicker ways. The more problems you do, you're going to find quicker, better ways, more efficient ways to get there. So make sure you do enough problems to get you to that point. All right, so in this one, so let's start off with tangent. So tangent of theta is the same as what?
Sine over cosine.
Sine over cosine, good, Waken. So that means that tangent squared of theta is going to be equal to what?
Sine square of theta over cosine square of theta.
Good job, okay? Sine squared of theta over cosine squared of theta. That means I can replace tangent squared of theta with sine squared theta over cosine squared theta, okay? So Delgado, how does that help? That doesn't look like it's any better. Well, the denominator here for my second fraction is cosine squared theta. That means I need to make the denominator of this other term here cosine squared theta. But in math, I'm not allowed to just multiply denominators by whatever I want. However, I can multiply by 1 anytime I feel like it, right? So I can multiply that 2 by 1. But 1's not going to help me out. It's another form of 1 that I need to help me figure this out. What form of 1 is going to be?
Cosine squared theta over cosine square of theta.
Good. Cosine squared theta over cosine squared theta, right? So now I have the same denominator, right? Now I can combine these two fractions and add the numerators. I'm going to get 2 cosine squared theta plus 2 sine squared theta. And now you can see what's going to happen. I have those 2 2's in the numerator, right, as part of separate terms. So what can I do with those 2 2's? I can
Factor.
I can factor them. I can factor out the 2's, right? I can factor out the 2's. So if I factor out the 2's, right, I get that 2 times cosine squared theta plus sine squared theta, and I've seen that somewhere before, right? What is that? Cosine squared theta
Equals 1.
equals 1. So I can replace that whole thing by a
1.
1, right? So that becomes a 1. And a 1 times 2 is
2.
2, all day, every day, right? So this is looking a lot better. It's very close, not quite, but very close, right? So using this same idea of the identity, right? Let's see if I can go here. The identity, what would happen if I subtract sine squared from both sides of the identity?
Cosine square of theta is equal to 1 minus sine square of theta.
There you go, right? Cosine squared theta is equal to 1 minus sine squared theta. So I can replace that cosine square theta by 1 minus sine square theta. And lo and behold, I've seen that somewhere before, right? Give me a minute to write that down. So now let's see where we are, because that looked familiar. That looked like what we got on the left side. Is it the same thing?
It is.
It is. So that means we have verified the identity, okay? When we were working with the left side, we found that it was equal to, when we simplified it, 2 over 1 minus sine squared theta. And when I worked with the right side, I found that it was equal to the same thing. So that means that since they are equal, we have verified our identity. Not a just, no, maybe so.
Hey, can you go back 1 second, please?
The previous slide. There.
Perfect. Okay, thank you.
All right. So that should give you enough to get started. Again, this is not to replace you guys reading and taking notes, but you should have some notes to start with. What I would do now is, if you haven't read the section yet, read it and see what additional notes you need to add to what you've done today with me, and then add those to your notes. If you have already started working with my math lab, then this should help you out a little bit. The problems in my math lab are about this, but they do get more challenging. Okay? They do get more challenging. So make sure that you work with those and start to work on the more challenging ones. If there's one you can't figure out and you keep on getting it wrong, then shoot me a message on Gmail, or just post it on Google Classroom, and I'll look at them. Okay. So yeah, I hope these help, Sophia. I figured these would help you because they are on the same level, but they do, a lot of them are about this, so a little bit easier, but I've seen some that are harder. So if you get one of the harder ones, especially if you get it on a quiz and you don't understand how they got it, just shoot me a Gmail. I'll solve it for you and I'll send it back so that you know how to solve it for your future quiz. Any other questions that come up, feel free to email me or let me know. Again, I will be on tomorrow at about the same time. So then you will, if you need help tomorrow, I'll have a makeup live lesson, and as soon as I get the opportunity today, I will post this on our classroom, so you guys can access it through YouTube. I'll put the link so that you guys can access it. Okay?
Did you change the due dates for my math lab on Sundays?
Yes, it's going to be Sundays now. Sunday night, midnight is your due date for this. Just to keep it easier, I'm going to suggest to the faculty, but I think the year will be over by then. I think if you guys have a set due date for your stuff, it'll make it easier for you guys to time manage your
Thank you
classes.
for that.
But you know, my stuff will always be due on Sunday midnight, and it's always assigned on Monday. And I also put a schedule on the classroom assignment, so then that way you know.
Alrighty, thank you. Wow.
Don't leave yet. Don't anybody leave yet. Let me do something here. Let me take a picture of attendance, and then I'll tell you what we are going to do. Did anybody leave yet? No, nobody's left. Multiple pictures for attendance. One of the questions that's come up is, do I have to attend all of these? I think I addressed that with you guys already. The answer was no. But if you need help, by all means, come and get help. Okay, whenever you need. Does everybody have a sheet of paper, or maybe just grab the next sheet in your notebook? Okay, I'm going to mute everybody. If you want to say something, unmute yourself, but don't say something after I give you the instructions of what I want you to do. A. Okay, so the next page in your notebook, or grab a sheet of paper, and I need to be able to see everybody. Let me see if I can see it so I can see everybody. See everybody. No. Why won't you give me everybody? So annoying. I have everybody. There you go. That's exactly what I want to do, Asiana. But not with that picture. Okay. So this is what we're going to do. I need to draw mine too. S-A-V-E-R. Oh, perfect. Okay, Zachary, you're going to draw an S. You're an S. Anissa, you're a B. But a big S. You got to make it thicker, Zachary, because I can't see it. And I got to be able to see your face and the S. Nicole, you're an E. Martin, you're an R, right? Hudson, you're a P. Talia, you're an R. Anthony, O, a big O. Oceana, U, you're a U. Myra, you're a D. Brenda, you're a W. Talia, you're an E. Sierra, you're an L. Angelina, you're an L. I'm sorry, no, Angelina, you're a U. My fault. Sarah, you're a V. V as in Victor. Maristeli, you're a Y. Jennifer, you're an O. Waken, you're a U. You're a U. Sherman, am I going to be able to see you? Can you talk? I'm not going to be able to see you, right?
I have a microphone.
I'm not going to be able to see you though, right?
No, I don't have a camera.
Okay, so Christina, you're an A. Sophia O, you're an L. Sapphire, you're an L. Wakeland, did I call you?
So I got a U.
And Isabella, you're a heart. You're gonna put a heart. You got a U, you said?
Yeah.
All right, so give me a minute so I can do mine. Grab me a marker, baby. Okay, all right. No problem. I will do it today. You know, I am home now and I'm getting told what to do by a 10-year-old. I know. I'm just easy. I kid. All right. Jackie, I need you over here. All right. Waken moved. I had Waken talk and he moved. I shouldn't have had you talk. My fault, Waken. Yeah. And everybody moved now. Oh no. It's gonna look funny. All right, so hold your letters up. You're gonna take a picture. I can't see your face, Zachary. Nicole, turn yours a little bit because I'm getting a lot of glare.
Can you see my letter? Is it like, do I have to make it thicker?
Yeah, make it thicker or darker. There we go. Zachary, make yours darker. Oh, that's cool, Martin, but then I can't see your face, Martin. So you got to make it either dark. There you go.
Mr. Delgado, I forgot my letter.
My letter is going to look really gross now, but that's okay.
I need to find a marker.
Mr. Delgado.
Yeah, you got yours up? Yours is an art, Talia. I might have some of you change because I had some of you talking. There we go. There we go. I can see.
Suspense is killing me, Mr. Delgado. I just want to know what we're doing.
Don't worry, I will post it. Just don't worry. Give me a second.
Yeah, it's better now.
There you go. Good job. Talia, yours is not up.
I forgot my letter. Is
R.
it R?
You're an R. You're an R. But it's got to be dark so you can see it on the camera. Talia, you're going to change to an E. Sorry. Angelina, make yours darker. Sophia, oh, sorry. I'm going to have to make you. It's funny. Sophia, Sophia, you're a U now. Yeah, you're a U. Sophia, oh, you're a U. Sorry. Because some of the people moved around when, I don't know if it was because they talked or I changed the screen. I think it's probably because I changed the screen. So you're a U. Make it a U. Okay. I'm sorry, Sophia, you're a U. Sophia O, you're an A. Sophia O, you're an A. Sophia, you're a U.
Am I still an A?
No, Christina, now you're an L.
Okay.
Sorry.
No, it's okay.
There you go, Jennifer. Good job.
This
Oh,
video is gonna look so bad. That's backwards.
Make it darker.
The R.
Okay, take a picture, Jackie.
Take a picture of the
Okay,
last
1,
one.
2, 3. Got it? Okay. Christina, your L is backwards. Did you draw it right? There you go.
I did. Yeah, because I drew one, it looked backwards in the camera, but then I drew one backwards, so it wouldn't look backwards. But it looked so backwards.
That's just funny.
What does it say?
Okay.
I don't know what that letter is.
Hudson, make yours darker. Can't see yours. I love yours, Mario Stelly. Very cool. All right, you got the picture, Jackie? Wait. Here comes Hudson. Yours is backwards, Hudson. Just turn the page and draw it on the other side. Oh God, this is the worst 5 minutes of my life. I hate you right now. Really, really hate you right now. Mind you, all of this is being recorded, so I'm going to have to cut this out of the official review.
Does this go on YouTube, Mr.
Ready,
Delgado?
Hudson. Okay, here we go. Ready? Get the picture. Got the picture, Daggy? Yeah. All right. So now to find out what it says, and by the way, it's not spelled quite correctly. You're going to have to look on the Google Classroom. I'll post a picture there. Okay?
I can't wait to see what it says, even though it's not spelled right.
It's spelled all wrong, but you'll get the idea.
Oh, it says save.
Hey, Sapphire. Did you put one up? Did I call your name? Okay, I did. Good. Okay.
Can I read it?
Huh?
Can I read it?
My daughter wants to read it. Go ahead.
It says savor, proud, W, love you, heart.
Huh?
It was supposed to say we love you all, but you know, it didn't work out quite that way. People moved around a little bit. So.
Oh, I understand.
This is Saber Proud Love You.
Huh?
This is
What?
Saber Proud Love You.
Saber proud, we love you all. That was the idea.
Oh, I heard love you. I was like,
but the E moved around. That was funny. I got to figure out how to do that better. All right, guys. Have a wonderful afternoon. If you want to stay, because you want to go over it again, I'll be on for a while longer. I'm going to take a 5-minute break, and then I'll be back on. Okay?
alrighty, have a nice day, Mr. Delgado.
All righty. Bye-bye.